Hi, this is Mrs. Gamila. I'm going to talk here about properties of proportion. Here, if we have A, B, C, D, E, and F are proportional quantities, we can assume that A over B equals C over G equals E over F equals to M. And from this here, by doing cross multiplication, if we take the first with the M, it will give me A over B equals M. Then A equals BM. And if we take the second term, C over G equals M, then C equals GM. And if we take E over F equals M, then E equals FM. Here, if we have A, B, C, and G are proportional quantities, prove that this is happening. Now, here, we're going to begin by number 1. First, when we see problems like this, we begin by solving the left-hand side first, and then the right-hand side, and see if they are. Now, what did he give me here? He gave me that A, B, C, and D are proportional quantities. Then we're going to assume that A over B equals C over G. Then A, all of this is equal to M. Then A equals BM, and C equals GM. Now, we're going to use these here in our problem. Now, 2, instead of A, we're going to put BM. Plus 3, instead of C, we're going to put GM. In the denominator here, we're going to do the same. And here in the denominator, I have 7 instead of A, BM, minus 5 instead of C, GM. Then I have here, I can take M as a common factor. It will leave me with 2B plus 3D over, in the denominator 2, I can take M as the common factor. It will leave me with 7B minus 5G. I cancel the M with the M, and this is equal exactly to the right hand side. Now let's do problem number. Here we're going to do the same thing. The left hand side, A, instead of A we're going to put BM, plus C, instead of C we're going to put GM. But here in my denominator I have B and G, so I can keep them as they are. Here I can take M as a common factor. It will leave me B plus G, and in my denominator I have B plus G. Then this can go with that, and the result is M. Now I'll begin to look at the right hand side. I have A squared. Instead of A, I'm going to put BM, make it squared, plus C squared instead of C, GM, make it squared, over. Make sure that I want to get rid of all of the A's and the C's, and put instead of them terms with B, G, and M. So in the denominator here, I'm gonna change the A into BM, but I'll keep the B as it is. Plus, I'm gonna change the C into GM, and I'll keep the D as it is. Here, this will leave me with B squared, M squared, plus D squared, M squared, over. Here in my denominator, I'll have B squared, M, plus D squared, M. This is equal to, I can take a common factor up as M squared. It will leave me with B squared plus D squared. And down, I can take a common factor as M. It will leave me with B squared plus D squared. I can cancel this part by this part, and the M with the square, and this will leave me with M. So I have here, therefore, the left hand side equals the right hand side. In this problem 2, I have A, B, C, D, E, and F are positive proportion quantities. Yep, I'm going to write my part, which is A over B equals C over G equals E over F equals M. Then A equals BM, you can realize that the numerator equals the denominator multiplied by m. And C equals dm and E equals fm. Now let's use this. We have here the left-hand side. We have a square root of a squared is b m squared plus c squared, which is d m squared, plus e squared, which is fm squared, over b squared, keep it as it is, plus g squared, plus f squared. Why did I keep them as they are? Because I have them here in the numerator. This will give me the square root of b squared m squared plus d squared m squared plus f squared m squared over b squared plus d squared plus f squared. This will give me the square root of m squared common factor. Leave me with b squared plus d squared plus f squared over b squared plus d squared plus f squared. These will cancel together to leave me with the square root of m squared, which is equal to m. Now my right hand side, a over b. Instead of the a, I'm going to put bm, and I'll keep the b as it is. The b will cancel with the b, will leave me with m. Therefore, left-hand side equals right-hand side. Here I'm going to assume from here that I have a equals bm and c equals dm. Then I'm going to begin by taking the left-hand side. It will give me 5. Instead of a, I'm going to put bm minus 2. Instead of c, I'm going to put dm over 5 b. I'll keep them as they are because I have them in the numerator. And this is going to give me, I'm going to take m as a common factor. It will leave me with 5b minus 2g over 5b minus 2g. This will cancel with this, will leave me with m. Now my right hand side, I have 4. I remove a, put bm plus 3. I remove c, put gm over 4b. I'll leave it as it is, plus 3g. I'll leave it as it is. I'll take a common factor as m to leave me 4b plus 3g over 4b plus 3d. They will cancel together and it will leave me with m. Therefore, left hand side is equal to the right hand side. Now here there is another rule that states that the sum of antecedents over the sum of consequents equals one of the given ratios. What does this mean? These are sort of the numerators over the denominators, okay? Now, we have an example here. We have 9 over 15 is equal to 6 over 10 is equal to 3 over 5. Step number 1. If I add the first and the second term, it will give me still 3 over 5. Let's see. 9 plus 6 over 15 plus 10. This will give me 15 over 25, which is equal to 3 over 5. Now, if I add the second and the third term, it will give me still 3 over 5. Let's see. 6 plus 3 over 10 plus 5 equals 9 over 15, which is equal to 3 over 5. And if I add the 3 terms together, it will give me still the same ratio. Then 9 plus 6 plus 3 over 15 plus 10 plus 5 will give me 18 over 30, which is equal to 3 over 5. And if I add the first and the last, it will give me the same ratio. Now 9 plus 3 over 15 plus 5 will give me 12 over 20, which is equal to 3 over 5. Now let's do this example here. We have a plus b over 11 plus equals b plus c over 9 equals c plus a over 4. He wants to prove that a plus b plus c over 5a plus 4b plus 3c equals 6 over 25. Now, we have nothing to do here with the right-hand side because it's a number. We're going to work on the left-hand side. Now, how can we reach the numerator here from this stuff? Now, my first step is I'm going to try and add the 3 together. Now, let's try and add the 3 together. I will call this the first term, this the second term, and this the third term. Now, first plus second plus third equals a plus b plus b plus c plus c plus a over 11 plus 9 plus 4 equals. Here I'm going to add the like terms. I have 2a plus 2b plus 2c over 4. Now, if I divide by 2 up and down, it will leave me with a plus b plus c over, I divided 24 2 by 2, it will leave me with 12. Now, this is my first part. Here I have a plus b plus c. Here I have a plus b plus c. Okay? By the way, if I put this over that, it will give me this over that too, as we said before. Now we fixed the upper part, we need to fix the lower part. What do we want here? We want to have 5a. We have a in the first term and a in the last term. But we have to use these two terms to find the 5a. Okay, let's begin by that. Then, if we multiply the first term by 3, 3 multiplied by the first term, and we multiply the last term by 2, 2 multiplied by the third term, then I add them together. This will help me to find my 5a. Now let's try to do that. Now let's do this operation. It will be 3 by the first term, 3a plus 3b over 3 by 11 is 33, plus 2 by the third term. It will give me 2c plus 2a over 2 multiplied by 4, it will give me 8. So these together will give me, we have here 3a and 2a would give me the 5a that I need, plus 3b plus 2c over 41. Okay, now I have my 5a, I have 3b, I need one more b, and I have 2c, I need one more c. So, if I add the second term, I will get my extra b and my extra c. And I'm going to add to this here the second term. So, plus b plus c over plus 9. So this will give me 5a as it is. It will give me the 4b that I need, and it will give me the 3c over 41 plus 9 is 50. Now I have this part is like the numerator here, and this part, the second part, is like the denominator. Then I'm just going to fix the fractions to see my final answer. Now from 1 and 2, I'm going to put it but in a different order. I have here I'm going to put it equal to, this is a fraction equal to a fraction. This was divided by 12, so I'm going to put my 12 here. Okay? And in the denominator, it will be 5a plus 4b plus 3c. Well, I'm going to put my 50 here. Here, the left-hand side is the same. I only need to simplify this. It will give me 6 over 25. Then I proved my problem. It can be done by many ways, but this is one of the ways. Here in this one here, he's giving me all of these, and he wants to prove that a over 2b equals x over y. And take a glance on our problem. We can realize here that we have a, b, c on the top in the numerator, and we have the x and the y in the denominator, while here they don't have them the same order. So we try to arrange this a little bit. We will make it a over x equals 2b over y. This will be a over x equals 2b over y, which is the same thing, but it's easier to solve it like that. Now we'll begin step number 1. What do we want to find here? We want to find a over x. Now here we can see a in the first term. Here is a over x, and we can see it here in the last term. Okay? So let's try to add the first term and the last term first. This is my first, my second, and my third. So add the first term and the last term. So a plus 4b plus 7c plus a over x plus 2y plus 5z plus x. This will give me what? It will give me 2a plus 4b plus 7c over. Down it will give me 2x plus 2y plus 5z. Fine. What do I need to do here? I need only the a and the x. So I want to get rid of this stuff. Here I will see that my middle term has 4b and 7c, but it's with positive. So if I just add it, it's going to add to it. It will not remove it. So I just subtract. Here I'm going to subtract from this the second term. So if I subtract it, I'm going to change the signs. So it will be minus 4b minus 7c over minus 2y minus 5z. Now, if I do my further calculations, it will give me this will cancel with this, and this will cancel with that. Then this will cancel with this, and this will cancel with that. It will leave me with 2a over 2x. The 2 will go with the 2. It will leave me with a over x, which looks like this part. Number 2 here. I'm going to look at the second part, which is 2b over y. How can I obtain 2b from here? I have b here in my first one, and I have b in my second one. So let's begin by adding them first. 1 plus 2. Here I have a plus 4b plus 4b plus 7c over x plus 2y plus 2y plus 5z. I want to keep the b and to keep the y. So this will simplify to 8b plus a plus 7c over 4y plus x plus 5z. Now, how can I get rid of this part? Here I can see that I have these two terms in number 3, but I have them with a positive sign. So I'm going to make this minus the third one. So if I do it minus the third one, it would give me minus 7c minus a over minus 5z minus x. So the 7c goes with the 7c, and the a goes with the negative a, goes with the negative x, and the plus 5z goes with the negative 5z. And this leaves me with 8b over 4y, which simplifies to 2b over y, which is like this part. يبقى from 1 and 2, a over x equals 2b over y. And here we have, he wants me to prove this. Now let's take a quick look. We have here the x, the 2y, and the z on the top, like here. And we have here 3a and 5c at the bottom, and here the same thing. So let's begin by doing the left hand side here. So we have here, if we take the first term, the first, this is the second, and this is the third. Let's look at the numerator here. We need from the first, we need it as it is. So we take the first, and we add to it twice the second, because I need 2y, and here I have only y. يبقى plus 2 times the second. And I subtract from it the third, because it's minus z. And here I have plus z. يبقى minus the third. So it will give me x plus 2y minus z over a minus 2b plus, don't forget that we're multiplying this term by 2, plus 2b minus 4c, and then we're going to subtract from it the third term, minus c plus 2a, because minus times minus is plus. Then we'll see what's going to happen. The numerator will remain as it is, the denominator. We'll get rid of this, and we'll have negative 4c minus c is negative 5c plus 2a, و-a هيبقى 3a. يبقى it will give me x plus 2y minus z over 3a minus 5c, which is the same as the left hand side. Now let's look at the right hand side. He wants here y plus 2z. يبقى he's going to deal with the first one. هيبقى the first one plus 2z. يبقى plus 2 multiplied by the third. Now let's look at the right hand side. We have here y plus 2z. We can take this y. يبقى we need the second term. We want to add to it 2 multiplied by the third term. Now let's see what's going to happen. My second term is y over b minus 2c, and I'm going to add to it 2 multiplied by the third term, which is 2z, over 2 multiplied by the third term, which is 2c, minus 4a. This is going to give me here positive 2c and negative 2c. It's going to give me with y plus 2z over b minus 4a, which is like the right hand side. Therefore, the right hand side is equal to the left hand side. Thank you. I hope it was clear.